Hey guys, so we are going to take a little bit of a closer look at a triple beam balance. And first of all, I just want to show you what one looks like in the actual lab. So if you look in the back of the room, I have a few of these, but this is one right here. And this is used to take the mass of objects and the unit of grams. And we use these little sliders and we move them along the track. And we are able to then determine the mass of the object by seeing how many times we had to move our little slider. So we use this to measure the mass of larger objects in the lab that our digital scale can't mass because it's too big. And they are also easier because you don't have to plug them in, so they're portable. So you guys might have used these before, but I want to go over just best practices, how to use them again, and how to read. More specifically, how do you make sure you have an accurate reading? So you might know how to get the line level, but do you know how to actually then add up all the numbers to read it correctly? So we're going to use this virtual triple beam balance just right now for me to show you how it works. Make sure you're paying attention because I will put some questions in the video to ask you to do a reading instead of just me doing the reading, but we're going to do the first couple together. So we'll start with some paper clips. So if we look here, our little arrow is above the black line. That means that we need to add mass to the scale. If the arrow is above it, it means you need to add more mass. And if the arrow goes below it, it means you've gone too far and you need to move the slider to take it away. And we're looking for it to be perfectly even with that little black line. So first thing I'm going to do is I'm going to start at the top and move it. And when I moved it to 10, the little arrow dipped below the black line, so I know I've gone too far. So I'm going to scoot it back. Now, if it's not 10 grams, it's probably not going to be 100 grams, but we can still just check and see that, woo, yeah, that's way too far. So we're going to back that up. So now, since it's not yet to 10, I'm going to go in increments of 1. So 1, 2, 3, 4, 5. So in this program, it kind of shows you where your little red arrow is. And if you put your mouse over the red arrow, you can see that it's pointing directly to 5 right now, but our arrow is still above the line. So I need to scoot it a little bit more. So I'm going to scoot it over until I'm perfectly level with that line. You can see our arrow is perfectly level when I'm right here. So if I look at where it's pointing, it is 5, and then I need to count the tick marks. So 1, 2, 3, 4 tick marks. So 5.4 grams is our answer for the mass of the paper clips. Okay, so let's say we would like to add a cone with the paper clips. So I'm going to start over from the beginning. And again, I'm going to start at the top again. 10, we haven't even moved it down. So nope, 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 nope. All right, so I need to start at the 100 slider. And you guys will obviously start realizing this when you're using it. Not 100, 200, nope, 300, 400. Wow. So we've maxed it out to 500, and we still need to add mass. So if we've made it all the way to 500, now I can start adding it in increments of 10. All right, we're finally starting to see the arrow go down. So if you look over at the arrow, it's finally starting to go down. All right, and we just went a little bit below it. So if you look right here, we're a little bit below it. So I need to go back one increment of 10. So right now we're at 540, but we haven't lined it up perfectly, so I need to add in some increments of 1. So 540 All right, we're getting close. All right, and that zooming in feature means I'm pretty close. We're at 547, and I need to find out my decimal point. Looks like we're getting close. Perfect. So we are at 547, and then we are at 0.4 again. So 547.4. And remember, our unit here is grams. So that is how much those would weigh together. All right, so I'm going to put the light bulb up, and I'm going to do the sliders for you guys, but I want you to figure out what the reading is once I get the sliders in place. So I want to put them all back in the beginning. All right, so I'm going to start my increments of 10. All right. All right, 300's too far, so I'm going to go back to 200. Now I'm going to add my 10s. All right, 50's too far, so I'm going to go back to 40. So right now I'm at, well, I'm not going to tell you because I'm going to ask you to figure it out. So I'm going to move this until I get it perfectly aligned. All right. So I want you guys to look at that and add them all up and determine what you think the correct reading would be. Okay, so I hope that you figured it out and that your answer would be 245.6 grams. Okay, we're going to do one more. And we're going to mass the weight, or take the mass of the cube. Okay, so because it looks pretty big, I'm going to start with 100. Yeah. All right, so move back to 400. And then I'm going to add increments of 10. That looks pretty close. So like my line. I'm going to go back because it hasn't zoomed in. I'm going to add it in increments of 10. Or in increments of 1, I'm sorry. All right, that's better. Okay, so I want you to look at this and determine what you think the correct answer is. All right, and hopefully you got the same answer I did, which is 429.3 grams. Okay, so hopefully that makes sense, and hopefully that you will be able to use one of these in an actual lab setting, and we will have some practice with that as well, so that you make sure that you know how to not only use a virtual one or watch me use a virtual one, but you can also use one of the actual ones in a lab setting. So yeah, you will have a worksheet for homework that has some problems like this, so feel free to rewatch this video if you need to, and again, make sure you know how to add up all of the individual readings to get the full reading, and that you always go out to the tenths place. Okay, bye.